more antiderivatives. So on this one, we don't know special rules yet for antiderivatives, which we will learn them. So what we need to do is go ahead and we're going to FOIL this out first. So I've got x squared plus 6x plus 9. So we're going to multiply the polynomial x plus 3 times x plus 3. And then we're going to find the antiderivative of this. So we're going to raise it by 1 and put it over that power, plus raise it by 1 and put it over that new power, plus 9x plus c. We can simplify this a bit. The antiderivative is 1/3 x cubed plus 3x squared plus 9x plus c. I'm not going to do the check on that one. The next one, again, we don't know any special rules, so we want to go ahead and simplify this first. So x divided by x cubed is x to the negative second, minus 5 divided by x cubed would be 5x to the negative third. So when I take the antiderivative of this, I get x to the negative first over negative 1. Remember, we're raising it by 1. So 5x to the raise it by 1 power gives me negative 2 over negative 2 plus c. So the antiderivative is negative 1 over x when I'm cleaning this up. We have a negative negative, so it actually makes it positive 5/2. And the x squared goes on the bottom plus c. And we're done. Again, I'm not going to do a check on that one either. Plenty more examples here. What this looks like is an entirely different type of problem, but it's the exact same thing. It's just an indefinite integral. And really, look at the difference. This one, they're giving me an equation, and this one, it's not an equation form. This is an integration sign. So, it's a new symbol for us. What it means is that we're going to use the rules of antiderivatives. So when we find the antiderivative of this, the integral of this, we're just using the same rules. So we'll put an x on here and put plus c. Now, if you want to do the check, which you can do every time, take the derivative of this, which would give you 5, and the derivative of the c is 0. So we know we have the correct answer. So this one said take the integral with respect to x. This one, on the other hand, says take the integral with respect to y. So instead of putting an x on our answer because it said with respect to x, we're going to take and put a y with this because it's with respect to y. So the answer on this one would be 5y plus c. Continuing on here, take the integral of 5x squared. We take the 5, rewrite the x, raise it by 1, put it over that new power, plus c. We could clean this up a little bit by putting 5/3 x to the third plus c. But this is as far as we can take it. Again, you can do a check every time. Bring the 3 out front, multiply those together, get 5, lower it by 1 gives you x squared. Next problems, I would recommend rewriting the integral on this in this problem so that you can see the negative 2. Make it easier for people to take the integral of it. So we will write negative 7 x to the negative 1, because that's raising it by 1, putting it over that power, plus c. I'll clean this up just a bit. So I get 7. This goes on the bottom, 7 over x plus c. And the next one, all these are with respect to x, so that's why I keep putting an x on them. We'll just go ahead and start taking the integral. We get 3x to the second over 2 plus x plus c. You can stop. Last example on this slide, we'll rewrite this first of all. And when we take the integral of it, we get 2/3 x to the 1/2. X to the 3/2, raise it by 1, put it over that power, plus c. We'll clean this up. 2/3 divided by 3/2 really is 4/9. X to the 3/2 plus c. Maybe you don't feel comfortable with that, you can check it. 3/2 times 4/9 is 12/18, which does reduce to 2/3. All I need to talk about left is the trig integrals, and that will be the end of today's topic.